support now. And okay, so let's get started. So I basically, I just want to briefly outline how I have structured this class. So I hope you all have seen the course support page. This is basically the week 0, that's the module 0. We have a general course information. We have a course welcome with a welcome from my end, quick introductory statement. And I would like very much learn from you. Please take a minute to introduce yourself. Then there's an outline of the course specific requirements. So we will need Excel. We talked about this. Who had troubles installing R? All right. Okay, decent number. Okay. So what were the problems? Just to get a quick taste.
It just wasn't opening. Yeah.
It was not opening. Okay, good. Let's look at it after class. Is that okay? Let's do a little bit of a breakout session after. It shouldn't be a big deal. Anybody with an iPad or a Chromebook? No. Okay, that's good news. Because it's a little trickier there. Who has Windows 11? Okay, also good news. Good, perfect. So it's technically it's a little challenging. I've tried to deviate from asking you to download R and R Studio, but it's just easier to work locally. So I'm going through this exercise every semester that it doesn't work for everybody right away. It's a little bit of a challenge at times. It is R. Just for you to understand, so you have statistical software that does statistical analyses, and that sounds super simple and as simple as could be, and in principle it is, but most software is very expensive, and it doesn't really follow state of the art of statistical methods. R, and this is why I'm a strong believer into using open source software. R and Python are just statistical software that are superior to those that are commercially available, and they cost a lot of money because A, they're very versatile in their use, and they're fun to program. Once you went through that initial learning curve, it's really fun to work in it. And B, you basically have state-of-the-art methodology that is publicly accessible. Somebody writes a PhD thesis on a statistical method in Singapore or anywhere else in the world, will post this publicly on GitHub just for the sake of contributing to the academic community. You can download this and you can use this right after he defended his PhD thesis. You can use this on your data. So I just believe in it being a superior method and just being a major step forward in the context of open science. So that's why I think learning R and knowing a bit about it is of value. Many of you may never use R again and hear about it now in this class and like look at me like I'm from a different planet. I understand that, but it's basically some of you may use R at one point in their lives. These codes that I'm providing to you are codes that I use in my daily routine, and they will be helpful in case you choose to go anywhere in the direction in data analytics or statistics or research. So it's useful. These are useful codes. I'm not teaching you this for no reason. Good, but this is R, and we're only skimming the surface of it, but enough that you kind of have a little bit of a code library at your disposition, and you may get a little bit of a taste, and it may interest you down the road. Good. So this is course requirements, Excel, R. Rest of that, please get the book. It will be important that you follow along with the chapters that we're discussing. It's a very good book. I've been teaching this now for 3 years. And I do like the books. I do like the examples, and it's very useful to have it at your disposition. It will be helpful for exams and homeworks and deeper understanding of the subject matter. You can get it from the library as well. I think there are copies available. There's also a virtual cafe where you can just exchange ideas, exchange comments. Feel free to utilize this here on the discussion board. I will not look at it. So if you want to complain about me, go ahead. So then there's also in the discussion, there's also course-specific questions. you have course material, ask the class, ask the instructor. I'm saying this every semester. Occasionally it's being used. I really emphasize this. Use the discussion board, communicate with the community of your class and communicate with me. If I don't respond, I try to be observant of this discussion board. If I don't react to a question, shoot me an email, say I posted something on the discussion board. In turn, if you send me a question to my email, I will ask you to post it on the discussion board that everybody has access to that response. I think it's an efficient way of communicating, and I've taught a couple of online classes, and this is just the most important feature of an online class. And I'm planning to have taught this, or since the pandemic, basically, I've taught this class as kind of this hybrid, and I have all the material online at all times. Everything will be online. Everything is on a computer. Please bring your computer for every class. Make sure it's charged because we're going to use it. And this just works very efficiently. So you will be able to essentially do all the exercises, all the homeworks, or all Excel exercises. If you choose to do the homework with pen and paper, be my guest, do it. Just post snapshots. Post the snapshots, submit the snapshots. But I will want to see the same calculations that you would have done in Excel. That is the only condition, but it's perfectly fine. If you want to use something else, it's fine. If somebody wants to use numbers or Google Sheets, please convert it to an Excel format. I can look at numbers, I can look at sheets. It's not really a problem. I just want to have the same access to all the functions and all the calculations as for the rest of the class, because it's basically graded as a collective, right? Good. Then we have the exams, quizzes, exams, all online. The way this basically is designed, I have expanding my pool of questions with every semester. So at this point, latest, so I did my last question pool last weekend. I'm going to do another one this weekend. So I'm expanding my pool of questions. We're now at like close to 1,500. So basically, I have this pool of questions from which your exams will be randomized from. So once we write a quiz or an exam, each of you will have a different exam, but it is aliquoted in a randomized fashion. So each of you has an equal chance to get the tough questions and get the easy questions. So I believe in probabilities and I believe in randomization. So this is a fair approach to that. I will, in addition to that, I will minuscule subfraction of these tests will be accessible to you, of these test questions will be accessible to you in the form of practice quizzes. And you will have with each question, with each module, with each chapter, you will have practice quizzes that you kind of get a taste of how the questions will look like. So it's multiple choice, fill in the blanks, it's calculations. There will be calculations. So it's a mixed bag of different questions that you will be facing on the quiz. But they're all easy to answer. They're all possible to answer based on what we learn in class. Please do not rely on the practice quizzes per se. Some of your colleagues have learned it the harder way, that this is not a good idea, and it's not a good idea to rely on the quizzes alone, on the practice quizzes alone. You will need to study for these exams. Good. What else? What else? Yep. Okay. Any questions about anything? If not, we can briefly talk about the syllabus. I hope you have all seen the syllabus. I have posted it in the module. And I just want to quickly go through the details, the practicalities. So we have an office, we have an RBs to be installed in our studio. We do that later. This is the book. This is an optional book. Those of you that have an interest in data analytics and statistics, highly recommend it. It's free. It's an open source textbook. is totally for free to download. So those of you that wanted to dig deep into the topic, highly recommend Open Intro. It really is a great book. So most of you, I understand, are pre-med, pre-psych. Yeah, I see some nodding. Okay, good. So Nolan and Heinz, they basically created this introductory statistics for pre-psych. So it's undergrad level for those that want to specialize in psychology. The examples we do in class are basically all focused on some, either they're more general or they're focused on something that is somewhat psychologically inclined. Whenever I'm being asked to provide an example, I will gravitate towards a medical example, somewhere usually from my world. So I do research in chronic kidney disease with a focus on dialysis therapy. Amongst many hats that I wear, I also work in the capacity of research scientist with a focus on epidemiology and data analytics. So I will gravitate towards a dialysis example, blood pressure example, or something along these lines. So you get a mixed bags of different topics. So it should be fun. Good. So we do the following things you will be graded on. So there are a couple of tougher ones, which are the exams. That's the heavyweight. That's like solid 600 points. That's 60% of the class. So you will need to study for the exams. We do 3 quizzes. These are simple 20 minutes quizzes, quick check in 50 points. Altogether, this sums up to 1,000. You get a couple of very low hanging fruits. That's the practice labs. That's 5. These are altogether worth 50 points. The practice labs essentially are, we're doing examples in class using Excel. The practice labs are basically summarizing these examples and doing these examples in R. You will get the code from me. So you just need to run along with me and run that code. As simple as could be. The output of that, you copy in a file and you submit to me. I just want to see you ran it and you followed along and you have incorporated and you have that code somewhere in your files. In case down the road in 10 years, you do some analysis, you have that code. And if you do R, it may be helpful to you. So that's the idea of the practice labs. You will not become expert programmers, and that's not the focus of the class, but I think it makes a lot of sense to do some data analytics and to see how it's done out there in the real world. I think there's just benefit to that. Good. Discussion board. Good. Discussion board are basically, we're not really doing discussion board. What we do is there are discussion topics. I've hand selected 10 videos that are talking about topics in statistics that are somewhat aligning with the topics that we're discussing in class. 2 of those have posted already that you can see in the module. I want to highlight particularly the second one from Dan Bricklian. Was it now? No. Oh, yeah. Yeah. So Dan Bricklian is a very remarkable man, and he's basically the inventor of the electronic spreadsheet. So he's actually, when you use Excel, he's the guy who invented it. And when you think about it, imagine the things you do or you may have seen somebody else do in Excel. If you would need to do this by hand and you make one mistake in the beginning, you're spending hours and hours redoing things. You're spending hours and hours just doing like very laborious work. With the invention of a spreadsheet, the world has changed. So it's quite remarkable to hear him speak about his experience. So what is being asked from you is to kind of give some angle, some perspective of what you have seen, and to kind of comment, either answering a question or just give a general comment about what you thought when you saw that video. So there are 10 different topics. You're being asked to respond to each of them. Gives you 5 points each, sums up to 50 points. Don't miss the deadlines, they're listed on the syllabus. Just make sure that you submit on time. Then you get 4 points. That's a very low-hanging fruit. Same as the practice lab, so that's 100 points, which I'm giving you like literally as a present. You just need to follow along. Good. Homework, that's a little bit more time intensive, but it's not terrible. It's interesting examples, basically using the methods that we have discussed in class, using them in a use case that I am presenting as a homework. It's usually not complicated. It's building some averages, standard deviations, doing a linear regression, like things that we discuss in class. Shouldn't be too hard. Will take a little bit of a time, maybe challenging to get a good head start in Excel and kind of get started in Excel. But once you overcame that, I think it should be easy. It's worth 150 points. Good. So that is the weight of the respective items. Any questions on this so far? Was or kind of clear? Yeah. Good. So there's an outline. Late submissions will be penalized with 10% each day late. Exams, so we're doing, so they're a little longer. So the midterm is 1 hour. The final is a little longer. It's like 1 hour 20 or so. I usually go by 2 minutes a question. That's like, it's usually ample time. Even if there are calculations, I think in 2 minutes you should be able to solve the calculations. The grade outline and the grading scale is presented here. So from 950 to 1000, you get an A. Everything below A minus, less than 900 B, less than 800 is a C. And I hope to see nobody down there. Okay, good. So the outline. So today we just do a little bit introduction and a course outline, discussing about some basic housekeeping rules. So you see here, basically in the middle, you see the topic. The respective module will match the module numbering on Canvas. And you see in the right column, you see the deliverables with the respective deadlines. I timed deadlines, so you get for a practice labs, you get 1 week, which should be easily doable. Homework is 2 weeks. Discussion topics, they're lingering around for like a week, week and a half, depending on whether there's a holiday or whether what day of the week is posted. The quizzes, so we have the first quiz beginning of February, so that's in like 2.5 weeks. That basically will cover the first 4 chapters. So we have the introduction, frequency distribution that we do on Monday, visual displays of data, and the central tendency and variability. So that's, you all know, so that's going to be simple. You all know the basics about of a mean and the standard deviation. It's basically just carrying this further, giving some additional information on alternatives to a mean and the standard deviation. So there are different markers of a central tendency and different markers of a variability, and we're just going to be discussing those. This coincides with a lab day. So you have basically after each larger block of topic, there's a lab day. Lab day is the day where I can get to torture you with R. And so we're talking about R. We're going to go through different codes and different functions. And I'm going to explain to you how the examples that we did in the preceding classes can be solved in R. And yeah, as said, at the end of the day, at the end of lab day, you have a code ready that you have run and that you kind of have been explained by me. And you can just finish practice lab 2. It's usually then easy to solve. Shouldn't be a problem. Good. So we're moving over after the first block, ending with quiz 1. We're moving to sampling and probability. This is a little bit more research inclined topic. Then we're getting to the normal curve. So we're only doing parametric tests. Parametric tests have as the underlying hypothesis, underlying assumption, that the data is normally distributed and distributes along a normal distribution curve, which means it's a bell-shaped, symmetric unimodal with one highest peak. distribution. We are only doing one non-parametric test, which is the very last topic that we do, is the chi-squared test, but more about that later on. But basically, we're talking about the normal curve in module 8. That's chapter 3, 4, 5. It's chapter 5. Then we start with hypothesis testing. And that essentially will build the segue into more advanced statistics, more advanced within the context of the introductory statistics. We're doing hypothesis testing, we're doing confidence intervals, we also talk about effect sizes and statistical power in hypothesis testing, which essentially is, that's in the realm of like how research is being done. So that will be quite insightful in terms of research. We will then move on to t-distribution and do single sample t-test, paired sample t-test, independent sample t-test, followed by the midterm exam. For some interesting reason, you have the midterm exam 2 weeks after the F slot. So I'm being fair to you with the other class. The midterm will end with module 10. So the material covered is up until confidence intervals. The t-distribution we will basically discuss, but the midterm exam will only cover up until module 10. I don't know why it's so late for you guys, but I've been instructed to do it on that day. Then we do we're reviewing t-test, and we do ANOVA. I don't want to go into too much detail, but t-distribution t-test basically compares two samples. So you have two little sample populations. So let's say you have two groups of students that scored on an exam, and then you have another group, and you compare these two groups. That's what the t-distribution does basically. If you have 3 groups, then you do an ANOVA. If you want to know whether there's an association between the exam grade and the absence in class, that's when you would do a correlation or linear regression. So that's kind of along the line. So we're comparing groups, we're comparing little samples, and we then will find associations between different variables. And with correlation and regression, chi-squared is then the non-parametric test that I mentioned. But basically after the midterm, we're basically moving on to analysis of variance, ANOVA. This is the second homework. Then essentially the second quiz will basically cover all of this. We have then correlation and linear regression, chi-squared, that closes the topic. So midterm is up until chapter 8, confidence intervals, effect size, and statistical power. The final exam is covering all 18 minus chapter 14, so it's 17 chapters on the final. So the final is quite involved. So you will need to follow along with what we're doing. So it's cumulative on both exams. But it's going to be fine. And you have the recordings. You can go through the recordings. Off note, the exams are open notes. That means you can use the book, you can use your notes, but there will be a lot of material to cover. So you will need to know where to look for that information that you're being asked for. So I emphasize on its open notes. That includes your own personal notes. These can be on the computer because the quizzes are on the computer too. That's fine. No Google, no messaging, no exchange with anybody else, but you can use your own scribble notes. Good. Any questions? No? Okay. All right. We do then a review for the final. That's on the 8th, on the 17th final exam, and then you basically you have passed this class. Good. This after that is kind of the same language as you know from other classes. Accommodations. If anybody has accommodations, I happily grant them, but give me the documentation as soon as possible. I would like to conclude this all in the beginning of the class. So don't So give it to me in the first 2-3 weeks that we're on the same page. I'd rather not get them later in the course of the class. Okay, any question on the syllabus? If not, we can move on. So we talked about the modules, syllabus. The modules are designed in that fashion that you basically, oops. So you basically have an overview, you have then a lecture part of it. You have on the main lecture 1, this is where you find the Zoom link. Those of you that want to zoom in, it counts as an absence, so it doesn't replace in physical presence. Then you usually have either a PDF or a PowerPoint presentation, which is the slide deck for the class that's accompanying the chapter. Then you have pretty much in every class, you're going to have an Excel spreadsheet. Who is really computer savvy? Anybody? No. Okay, just for you to kind of know about this, so you will have different. So you basically have the file name. Everything before the period is the file name, and that in the end is the so-called extension. XLSX indicates it's an Excel spreadsheet. The PDF and PPTX, that's PowerPoint is PPTX. PDF is a PDF file that's basically a printed document. And then you have .r, that's an R code. The R code can be opened with R and RStudio. Can also be opened with a text, with the text editor. It's basically nothing else but a text file. And we'll talk about this once we open R. Okay, I highly recommend to create a folder on the desktop that basically is labeled as STAT1021, or you call it statistics or whatever you want to call it. And you create a subfolder for each chapter that we're discussing. That has basically the purpose of you having a system and organization right from the start, because we're doing 24 modules. 24 modules, and you have an average between 2, 3, 4 files each module. I highly recommend you download all these files. And if you have 3 multiplied by 24, that's like 72 files. If it were 4, then it's basically 96. So you have a large number of files. If you want to stay organized, organize yourself right from the start. I highly recommend this. Good. Once you have downloaded this, those of you that who is working on the Office 365 of Yeshiva? Or do you all have local versions on your computer of Excel? No. Do you have local Excel versions on your local computer? Or are you using the Office 365 from Yeshiva? Okay, so that's, yes, that's this online account. The reason why I'm asking is, do you know how to operate it? Yeah, you can't. Okay, you use the OneDrive and. Okay, no, that's perfectly fine. So I'm recommending that you make yourself comfortable with using the OneDrive. So those of you that are not knowledgeable and using it, use the OneDrive, and you download the files from Canvas on that folder that I've just shown you, and then upload it in your OneDrive, because from there you can open it in Excel on the online system. And you don't have to purchase an Excel version. So it saves you the money, because your university is providing this as a service to you. It's kind of useful. Yeah, so this makes life a little easier. So you have basically, you have your whole Office 365, you have your OneDrive, that's basically a cloud drive. And then you have Excel, where you can open from OneDrive files work on them in Excel. And then if you go on File, you can download a copy. And this is how you get your Excel file back down, and you can submit it to me. Good. That's this. Good. Any questions on any of this? It's a little much walking you over through this, but it's going to be fun. We're going to get. If not, we can move on and kind of start talking a bit about statistics. And that's essentially just a little taste. We will talk more about this on Monday when we actually do this really first walkthrough through statistics and statistical methods. So what I just want to show, and this is on the PDF that is posted on the module. So statistics has always been around. This mathematics has been used very early in times. This has gone back to like before up the ancient Greeks, has gone over the Egyptians. It has continued the Chinese during the building of the Chinese War. Has then basically moved on to here. That's a picture of Reverend Thomas Bayes, who developed Bayes' theorem, which was quite fundamental for probability theory and the use of probability in all walks of life. Has then really carried on and has become more and more important. For example, probability theory was used during World War II, and the probability of so there's this story about when planes in World War II were shot down. So they did analyses, where is a plane to be most likely to be shot at, and they would strengthen this part of the plane that it wouldn't crash. So there's a lot of probability involved from earliest time on. And yeah, interesting topic also. So we've all gone through this terrible pandemic, right? And since then, we kind of learned the importance of epidemiology, which essentially led to us curbing this down to a level which now hopefully will soon be over. Epidemiology really started only quite recently. So there was mid of 18th century, there was a cholera epidemic in London in the UK. And there was a physician named John Snow. His name was really John Snow. Had nothing to do with the movie, the TV show character. So he was able to determine, based on the rates of the occurrence of cholera in certain parts of London, to identify a well from which water was fetched and drank that was contaminated with the virus. And that really is counted as the birth hour of epidemiology, because back then they had no idea about viruses. They had no idea that that actually was a thing. They didn't even know that unclean water could cause any disease. So they were actually postulating that it was the fog in London that would cause this disease. So it really was the birth hour of epidemiology. And since then, it has really stepped up to allow for us to really gain deep insights into disease dynamics in populations, which now quite prominently has definitely changed the world as we know it. The point at which it really became possible to do analyses on a large scale was really the invention of computers, inventions of spreadsheets, and furthering our technological advancements. And nowadays, when you think about it, with spreadsheets in the 1970s and 80s, it was able to do mathematical and arithmetics and mathematical operations, but it was possible to do statistics, but it was only possible in smaller numbers of patients. And that you will also find reflected if you go back to old research, you will find only small sample sizes because that's all they could work with. They found great groundbreaking things and they did great research, but essentially it was not the big data analytics we nowadays do. Nowadays, so I'm looking at data of like 500,000 patients followed over 10 years, and I do analyses in such large populations. And that essentially is just, it's a new era in which we're in. And nowadays you have artificial intelligence and you have machine learning methods that basically predict every move you take. You open a website, you go on online retail services, they know exactly what you want to look at. They know exactly what you want to buy. Not only do they know what you buy and they're suggesting it to you, they also fill their warehouses already with that item that you will most likely buy. That's how they can deliver within a day. And that's the time we live in. Everything is being predicted, everything is anticipated. It makes things more efficient and it improves the lives as we're experiencing it. And this is why statistics is just, I think understanding the basics of it is just of great importance on many levels. Okay, any questions? All right, then let's, not this. Good, let's, so I'm struggling a bit with this. Oh yeah. Okay, so but let's back that. Let's go back to the beginning. So first we need to understand some definitions. So part of this class is also that so there are various mainstays of statistics I want to discuss. One idea is to understand the different methods, to understand how to translate research and research questions into actual valid hypotheses, how to translate data available into variables that will be utilized in methods, and how to utilize these methods and that data to basically yield interpretable results. So that's part of this class, and this is what I envision to teach you over the course of the semester. And in addition to that, I think it's also important that you learn some of the terminology that is being used by statisticians, with the idea that maybe you're not doing the analysis yourself, but maybe you have a statistician doing them for you. You need to be able to communicate with the statistician, and you need to understand what the statistician is actually showing you. So that's part of the class in a way. And for that, you need definitions. For that, you need to understand some basic definitions of how you approach statistics and research. So firstly, you have a population, right? So when you want to understand the dynamics of a disease, the dynamics of, or whatever dynamics you're interested in of a population, you need to first define your population, your group of interest. And that is usually a very defined population. So you have, you can say all people in the world, which is hard to study, right? All American adults, equally hard to study. All residents of New York, also hard to study. For that very reason, you are creating samples that are representative of your population. So you randomly sample, and this is chapter 4, you randomly sample a subset of that population, and you're studying the dynamic in that sample. And you're utilizing the insights you get on the dynamics in that sample to extrapolate it to your population. So you have a sample, you study 20 people, and you say like, okay, so stop drinking sugary drinks with a lot of calories for the next 10 years, and that will lower your probability of developing diabetes. If that is true in my sample of 100 people, it's likely going to be the same in all residents of New York City. It's going to be the same in the US population. It's going to be the same in the world population. So that's kind of the idea. The problem is most samples are not necessarily representative of your population. And that's where the art comes in, because you need to sample a sample population that is representative of the greater population. But these are basically, just for the definitions, you have a population and you have a sample or sample population. Yes, please.
Is the law of large numbers?
The law of large numbers goes in that direction. If you, for example, excellent point, because essentially when you have, if you select a group of 100 individuals and you just randomly stop 100 people on the street and you say, do you have diabetes? With a prevalence of diabetes in the population of like 10%, your 100 people, hypothetically, 10 of them should be diabetics, which is likely not true because you may have a non-representative samples. If you study 2,000 people, you will likely have that prevalence and that probability of picking that percentage of individuals that is consistent with the prevalence estimates from the US. You will likely find that reflected in that population. And the larger your number gets, the more accurate your estimate gets. And that's not only true with percentages. That's not only true with the context of picking random people out of a population. That is also true when it comes to continuous variables. And we'll talk about this in a second. Okay, so, but let's backpedal. Okay, so a sample is a subset of a group of interest, a subset of a population. A survey that is surveying the entire group of interest, so the entire population, is a census. So all of you must have heard of the US Census, which is one of the largest censuses in the world, which is tremendous lot of effort, costs tremendous amounts of money, takes tremendous amounts of time, and is only done every 10 years. But it's super important data because you get a baseline of where the entire population stands. But it's not possible to conduct this every other month. So there's an organizational, financial reason why this cannot be done in a regular fashion. That's why samples are really the only way how to deal with the understanding of such dynamics or whatever prevalence you're interested in. And this is where the law of large numbers comes in, because if you sample a certain subset and that subset has a certain size, you will get an estimate which you can extrapolate to the US population. If you sample from all the major areas and you sample like decent samples, you will have an understanding of the population. Single observations are called records. So if you have one entry and there's Mr. Smith, Mr. Miller, Mr. Doe, I don't know, you have different records, and each of these individual records will be called a record. So that's the subject level. If you have repeated observation for one individuals, the level you're looking at this data is basically an assessment level. So then the single assessment is called a record. So then it's not the subject anymore. So it really depends on the level you're looking at this data. Is it subject level data or is it assessment level data? So it's important to distinguish. Good. Yeah. So census, records, and samples. And this is now the different parts of statistics. So in principle, statistics has three major goals, three major tasks. One is descriptive statistic. Secondly, it's inferential statistic. And thirdly, it's the informing and support of research and study design. The third one is something that is not mentioned in most books, but I think it's important to keep in mind that when you design a study, when you design research and you mean to answer a research question, you need to have a statistician on board telling you, what do I need to study? What variables do I need to capture? How often do I need to capture these variables? And what can I do with this data? This person needs a seat at the table to inform in his area of expertise. So that's why I think this is definitely an important additional task of statisticians. So let's start off with descriptive statistics. And this is just a quick first start into the topic. So my research involves a lot of epidemiology. So this is my personal interest, so to say. And I mentioned John Snow and the work he has done in London, but this has also then spread worldwide. And this is an overview of death rates in New York City in the 19th century. So what's interesting to see is that you have, so first of all, you have on the y-axis, this is a time series plot. A time series plot is characterized by having a time on the x-axis, and you follow a certain dependent variable on the y-axis, which is here the death rate per 1,000 population. And this is literally a rate. The definition of a rate as opposed to a count is that it is over a certain time period. So whenever somebody wants to tell you about a rate, you know that this needs to be over a certain time period. And it's of utmost importance that this time period is understood. So you basically have here the death rate per 1,000 population, and you have that shown over a certain period of time. So you see spikes in the death rates that are coinciding with certain epidemics that have happened in New York City or in the vicinity of New York City. So it's just interesting to see, because these descriptive statistics can here also be used to essentially draw inferences and do inferential statistics. So if you have step changes like that, you can basically draw inferences out of your descriptive statistics, and you can basically associate this with the occurrence of an epidemic somewhere in the vicinity. So this is descriptive statistics as the second big mainstay and task of statistics. And third and lastly, you have inferential statistics. So inferential statistics is statistics, or is a methodological approach, where you basically draw inferences from whatever you are observing as a dynamic. So here is something that you likely have seen in various contexts in elections. You may have seen that on the news. So basically, if you have a politician, be it the president, be it a representative or a senator, a governor, whatsoever, you have an approval and a disapproval rate. So if you have, you have two choices: you either approve or you disapprove, or thirdly, I have no opinion. That would be the third option. So that's why these two are not adding up to 100%. But you basically, you sample, and this is how these surveys are being conducted. So whether one of the research institutes are calling then a certain number of people, and they're basically asking, okay, so do you approve the actions of this governor, of this senator, of this politician? And you get either you get approved or you get disapproved, and you get a percentage. And this percentage here is shown again as a time series plot. If you get a certain estimate for approval over time, so they do this every month, you get an estimate of approval of your 100 people every month. So you call 100 people. But what you have around here, and that's interesting, and we will do this in chapter 8, to calculate the confidence interval, or the so-called margin of error. And this is likely what you have heard in the news. If you have an estimate of an approval rate, you will always have, at the very same time, at least in a serious in a serious news report, you will have a margin of error reported with that estimate. And this margin of error is a representation of the sample size and the certainty you have around that estimate that you're presenting. So if you say you have an approval rate of 41.9%, that comes with a certain level of uncertainty, which is from, let's say, from 35 to 46. You basically have this margin of error with a mean approval rate of 41.9%. So you estimate based on your sample is 41.9%. Given the sample size that is considerably smaller, of 100 people, for example, you get a certain level of uncertainty. And this is always being reported. And we will calculate this in chapter 8. So this will come again. But basically, this explains here this broad band around the actual estimate. And this is also what statistics does. So it basically gives you an estimate based on the sample dynamic that you're observing. And then it gives you the level of uncertainty. It gives you the probability that this is actually not true. So the definition of such a margin of error is basically, based on my sample, I estimate it to be 41.9. But I am only, let's say, 95% certain that the true population estimate, the true population approval, is within an interval from here to here. based on my sample. So it gives you this interval within which you are at a certain predefined probability, certain that you're capturing that population estimate, that population approval. Hope that makes sense. Any questions? Yes?
Is there always going to be a margin of error?
Yes. If you are studying a sample, you will always have variability, and you can, based on this variability, always determine a margin of error. Yes. It's actually very concerning if somebody would give you an estimate without a margin of error. And you also, your first question needs to be, what's the margin of error? What's the sample size? So if somebody gives you, okay, so X, whatever politician has an approval rating of 40%, your first thought process needs to be, okay, how many people did that research institute call? What was the variability? Because that variability of approval will be contained in the margin of error. And what made them choose these individuals? Because usually you have like these surveys that differ from each other depending on what party funded them, right? So it's you get these different estimates because they have something which is called a bias. So you need to know, is that sample that they have surveyed really representative to the US population? And that's usually, so this breaks a lot of surveys because you have biased samples and a lot of research, to be honest. For example, in the context of research, you know when a drug is being tested and it gets to that final stage where it gets FDA approval, that requires a lot of research. Fact is that all these studies that are being conducted until the point the FDA approves it are basically, and I'm not contesting what the FDA is doing, don't understand me wrong on that, but a lot of drugs that are being used in the overall Medicare population had been studied in a population that was never meant to essentially get. And that was basically never the main interest to essentially being administered. So a lot of study participants are younger. They're more likely to be college educated. So there's a lot of bias involved in all of this, but you're counting on replication, doing the study, doing that study here, that study here, that study here, doing the study over and over and over in different ways and fashion, different samples. You hope that the dynamic, if it's consistent, will be the dynamic you will also observe in the overall Medicare population, for example. So it's very interesting. When it comes to bias, this is it's a problematic topic in research in general, and that we will talk about this more in chapter 4 when it comes to a term that is called generalizability, because you need that random sample to really be able to draw inferences. Good, thank you. Excellent question. Good. Any other questions? No? Okay. Inferential statistics. Good. Oh, yeah. Good. So then I would like to move on now. So what's the level of understanding of Excel? Just generally, from my understanding, is like who is absolutely who has never used Excel in her entire life? Okay, all right. Thanks for sharing. Good. Excel. So as I said, a little bit of a side effect that I see in this class is like you get a little bit of exposure to Excel, which I believe will be helpful to you. So basically, Excel is organized in quite a simple format. So basically, you have up here, you have the tabs, and you have down below here, you have the different worksheets. Different worksheets are just different spreadsheets of that kind, where you basically have data in there. This data is organized in so-called cells. Cells contain data. This data can be words. This data can be numbers, it can be dates, it can be various different formats. What's inherent for each of these cells is that they have an address. This address is basically put together with the column and the row. So when you are in A1, you're basically in the very first, in column A and in row 1. If you go in B3, you're basically in column B and in row 3. You also see this reflected up here on the left upper corner. You see that very cell address reflected. Why is that important? Because you can do also calculations. And what I just quickly want to outline, 8 minutes over. Okay, so what I quickly want to outline, so there are two different ways of organizing this data. So we have here data of 4 individuals. We have Teresa, Sarah, John, and Nicole. These 4 individuals have 4 different ages, so they're 28, 26, 21, and 34. And their data has been captured over 2018. And they have earned $105, $110, $120, $140 by selling lemonade. And they basically, their skills in selling lemonade have improved from 2018 to 2019. And that is reflected here. The differentiation between these two inherent data blocks is the year. And if you have this arranged in such a redundant format where you have the name occurring 3 different times for each year once, this is called a so-called long format. Intuitive, right? The opposite to the long format, and this becomes important because we need to do this with a couple of classes. The opposite of the long format is the so-called wide format. And now for that, we open a second. So you can always copy cells if you select them and you press Command and C, like Caesar, Control on Windows. If you copy this in a different spreadsheet, you essentially have this transferred and copied into a different spreadsheet. You can delete now this, and you can arrange this now age in 2018. And this is the earning in 2018. And you can now just bring this data over there. You take these 4 entries here. You just want the values. You say now earning 2019. And you want to take these 4 over there. And you say earning 2020. And what you're seeing now is a so-called wide format. In a wide format, you do not have this redundancy, and each single record is a different individual. And you have different variables for each entry for each year. As opposed to this format, the long format, where the level of the degrees of freedom or the level of and at which you're looking at is basically individual at each year. So you have these repeated entries for each individual. And this is a very important distinction because you will need this in different formats for different analyses, right? So you have, so for R, you will need to basically change this into different formats for different functions. But again, this is wide format, and the other one is long format. In Excel, you can do wonderful things. You can basically do simple arithmetics, and you can also do more sophisticated functions, which we will do on Monday. On Monday, we're going to do frequency distribution, and we're going to create a frequency table. And you will not like Excel on Monday, I promise you that. But it's going to be fine. It's a learning curve, right? In the beginning, it's a little much, but it's like you will find the beauty and the the power of all these functions in what we're doing. So if you write in E6, you write D6 minus D2, you're basically calculating the difference between Teresa's earnings with lemonade sales in 2019 minus the sales in 2018. And that's simple, right? It's 10.5. If you want to continue now this calculation, and you also want to do this for Sarah, John, and Nicole, the only thing you need to do is you basically, you have here the formula, and you hover over this cell, and you have here in the right lower corner, you have a little spot where the cursor changes. It was first a solid white cross, now it's a solid black cross. And once you are there, you just need to click, keep it held, and pull it down. And now it basically shifts the formula down, and it shifts the frame of the formula. So now it calculates automatically 0, 2019 minus 0, 2018. And that's very powerful, because when you use this out in the real world, this makes your life super easy. And that's how you can basically utilize Excel for your purposes. Good. This is this. Any questions? I still have 4 minutes. Don't rush me. Don't let me. Okay. So then next we have the R code that I have posted, and I encourage you to kind of play around with it a bit. Nothing can happen, whatever you do. You have RStudio organized in 4 different quadrants. You have on the left upper quadrant, you have the script. This is the .r extension file. This is basically nothing else but a text file, which you can then utilize in RStudio to run that code. And you can do this with Control and Enter. You can run each of these codes. Left lower quadrant, you have the actual core piece. That's R. So RStudio basically grabs R and says like, okay, so you're doing this for me now. Takes the script, runs the script in R, and then you get all kinds of output here in the right lower quadrant, where, for example, you can see plots, you can create graphs and all kinds of different analyses in there. And up here on the right upper corner, you have the so-called environment, which basically contains all objects that you have created. So if you have a data frame, you will essentially see a data frame being created up there in the environment. So if you want to create this data frame of Teresa, Sarah, John, and Nicole, you just have to go into line 2 and run Control and Enter. And that creates automatically this data frame that we have in Excel. You can then carry on. If you press Control and Enter and you just play around with it, it does different things for you that you have told it to run for you. And that's the exercise that you can do. It's more for fun. This is, I posted this to that you kind of get a taste for R. With Control and Enter, you can run these lines and you can kind of familiarize yourself a bit with R. And you see then various things that R is doing, and these are different functions. But yeah, so that's pretty much all I had. I'm done for today. Have a nice evening. Those of you that need help with RStudio, please come to the front, see me.
Basically, I don't know if you remember, but last